Let's take a look at a couple geometric series together and see if we can find the sum of them together. I encourage you to grab some paper, something to write with, and let's do some math together. Alright, so right away, when we look at the series, we want to notice that this is a finite series. We know that this is a finite series because we know that the last term of the series is going to be 2 over 5 to the 4th power. So once we identify that it is a finite geometric series, then there's a formula that we can use to find the sum of these first n terms. And that formula that we're going to use is going to be S sub n, or the sum of n terms, is equal to a times the quantity of 1 minus r to the n power, all over 1 minus r. In this formula, a represents the first term of the series, r represents the common ratio, and n represents the number of terms. If we take a look at our series, we can see that the first term here is going to be 2, so we know our a value is going to be equal to 2. Now to find the common ratio, or find r, we just have to figure out what we're multiplying each of these terms by to get the next term. Now a quick way to do that is just to take a later term, like maybe we can find the second term, which is 2/5, and just divide it by the term right before it, so divide it by 2. So we divide it by 2, that's 2 over 1. That's going to be 2/5 multiplied by 1 over 2. The 2's are going to cross cancel, so the common ratio here is going to be 1/5. Now it's going to be the same ratio no matter which 2 you pick, so just for good measure, if you just want to practice this, 2/25 divided by the 2/5, so the third term divided by the second term, this is going to be the same thing as 2 over 25 times this 5 over 2. The 2's are going to cross cancel, and the 5 and 25 are going to cross cancel to make 1/5. And so this just means that to get each next term in our series, we're just going to keep multiplying by 1/5. Now to figure out n, or the number of terms, we can see here that this is going to be 2 over 5 to the 0 power, this is 2 over 5 to the first power, this is 2 over 5 to the second power, so this is going to be 2 over 5 to the third power, and we're finishing off at 2 over 5 to the 4th power. So it looks like we have a total of 1, 2, 3, 4, 5, or 5 different terms, so we have a total of 5 terms. And so if we plug in each of these values into our formula, we have 2 is going in for a. That's going to be multiplying by this 1 minus, and then what's r? It looks like r here is going to be 1/5. So I'm going to go ahead and just take this and write 1/5 in parentheses here. We're going to raise that 1/5 to the n power. We know n is going to be 5. So that's going to be the power for 1/5, or the exponent rather. And then this is going to be all over 1 minus r, and we know r here is going to be 1/5. So we're going to go ahead and take away 1/5. Now that we have all the pieces in the right spots, don't worry about actually calculating this. We can just throw this whole thing into a calculator. So feel free to pause the video real quick if you want to type that into a calculator yourself to make sure that you get the same value, and then unpause when you're ready to see the answer. But I'm going to get, when I put this into a calculator, I'm getting 2.499. This right here would be the sum of this finite series up to the 5th term. And while I did say it a little bit quickly earlier, I just want to go ahead and make sure that the n equals 5 is really clear here. Keep in mind that this 2 in the beginning, you could rewrite it as 2 over 5 to the 0th power, since 5 to the 0th power is just equal to 1, so 2 over 1 is just 2. This 2 over 5, you could just rewrite that as 2 over 5 to the 1st power, and then we can go ahead and see this third term. Instead of 2 over 25, you could write that as 2 over 5 to the 2nd power. And then they don't really show this 4th term here, they put this ... but we know that the next term in the series would be 2 over 5 to the 3rd power, just continuing that pattern. And then we end with this 2 over, and they give it to us in this exponential form, which is nice. This is 2 over 5 to the 4th power. So if you take a look here, we do have 1, 2, 3, 4, and 5 terms here. All right, so this first example was a finite geometric series. Let's take a look at another example together. In the second example, we're going to go ahead and find the sum of this series, where we have 8 plus this 8 over 7, plus 8 over 49, plus 8 over 343, plus 8 over 7 to the 4th power, and then this is going to continue on forever. Because we have this ... at the end, we know that this is going to be an infinite series as opposed to a finite series. That being said, make sure we don't use the same formula that we used earlier, which is just for a finite series. We have a different formula when we are dealing with an infinite series. For an infinite series, we're going to go ahead and use the formula S equals, or the sum is equal to, a over 1 minus r. Similar to the other formula, a represents the first term of the series, as well as r still represents the common ratio. Looking at our series, we can identify a pretty quickly. That's just going to be equal to 8 because that's the first term in this series. I'm going to go ahead and write that in. Now for the common ratio, just like we did earlier, just take any two terms in the series and just divide the later term by the earlier term. So I'm just going to go ahead and take this 8/7 here, and let's go ahead and divide that by 8. So if we divide that by 8, that's going to be the same thing as 8/7 multiplied by 1/8. Those 8s will cross cancel, so we're going to see our common ratio here is going to be 1/7. Just to confirm that real quick, for good measure, we can go ahead and take the next two terms and take this 8/49. Let's go ahead and divide that by the previous term, which is going to be 8/7. If we go ahead and do that, that's going to be 8/49 multiplied by 7/8. You're going to see it's really satisfying. Everything cancels out here, the 8s, and then the 7/49 makes 1/7. So to get each next term in the series, we're just going to keep multiplying by 1/7. All right, plugging our values into our formula now. For A, we're going to go ahead and say that is going to be 8, so that's going to go in for our numerator. And then underneath here, we have 1 minus r, so 1 we know is just 1, and then minus r is going to be 1/7. Okay, so if you'd like to pause the video now and go ahead and see if you can then simplify this whole complex fraction so that we get something a little bit nicer, feel free to do so. Or if you'd like to just do it with me, we can go ahead and just continue on. All right, so I'm just going to go ahead and put this 8 on top first, and then underneath it, we have 1 minus 1/7. That's really just going to end up being 6/7, right? So I'm going to go ahead and write 6/7 for the denominator. And so we really have here 8 divided by the 6/7, so 8 is going to be 8/1. Then we're going to go ahead and divide this by the 6/7. If we go ahead and divide this by 6/7, and then just like earlier, we can rewrite these division problems as multiplication problems. So we have 8/1, let's go ahead and multiply that by 7/6. Then if we can go ahead and cross cancel the 6 and 8, divide them both by 2 here, we're going to end up with 4 times 7, which is 28, and then 1 times 3 is going to be 3. And so the sum of this infinite geometric series is going to end up being 28/3. You can also rewrite this as 9 1/3 if you'd like. This would be the sum of this infinite geometric series. All right, so there you have two different examples of finding the sum of a series, specifically geometric series. Keep in mind that some of these series are going to be finite, so they have a limited number of terms, and sometimes they are infinite, and in each case you need a different formula, so make sure you take note of which one to use in each case. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful, and as always, keep up the great work that you're already doing.